Hello, class. Let's take a look at this problem we have right here. We have a common design requirement that an environment must fit a range of people who fall within the 5th percentile for women and the 95th percentile for men in designing an assembly work table. The sitting knee height must be considered, which is the distance from the bottom of the feet to the top of the knees. Males have a sitting knee height that is normally distributed with a mean of 21.4 and a standard deviation of 1.2. Females, on the other hand, have a mean of 19.4 and a standard deviation of 1.1. Use this information to answer the following questions. What is the minimum table clearance required to satisfy the requirements of fitting 95% of the men? Okay? So in other words, what is the minimum requirement? So this is a normal distribution type of problem, and we want to satisfy 95% of the men, okay? So that means that we want to be at the 95th percentile. So let's open StatCrunch to do this. StatCrunch can do this very, very effectively. Go to Stat, Calculators, and Normal. And let me move this up here just a tad. The mean for men is 21.4, the standard deviation is 1.2, and we want to be in the upper tail, and specifically we want 0.95 in the upper tail. So that gives us, 0.05 in the upper tail, okay, because this is 95%. So that gives me 23.37 or 23.4. Determine if the following statement is true, false. If there is a clearance of 95% of the males, there will certainly be a clearance for all women in the bottom 5%. Okay, well, the statement is true, okay, because the 95th percentile for men is greater than the 5% percentile for women. Okay, so the author is writing an exercise at the table with a clearance of 23.7 above the floor. What percentage of men fit into this table? Okay, so clearly the top 5%, okay, or the 95th percentile is 23.4. So what if it were 97.24? So the best way to do this is to put in 0.9724. No, I'm sorry. That's not right. Scratch that. Put in 23.7, okay, and then hit compute. And that's going to be 0.276, so I need to subtract that from 1. So 1 minus 0.027641015, and that gives us 97235985, or 9724. Okay, so if I'm looking for a height of 23.7, that's going to essentially be in the 97.23 percentile, okay? Remember what percentile means. Percentile is the value such that the area to the left of that value is whatever the percentage is. For example, a 95th percentile means that I'm looking for a value such that the area to the left of that value under the normal curve is 0.95. Remember that the area under the entire curve must be 1. So finding the 95th percentile is the same as finding the area in the tail, the upper tail, of 0.05, because 1 minus 0.95 is 0.05. Okay? What percentage of women fit in this table? Well, okay, now what I have to do is I have to actually change these requirements and make this 19.4 and make the standard deviation 1.1, and now hit compute. And then as you can see here, the percentage is extremely small, okay, such that if I subtract this from 1 minus 0.00004632, I get 0.99995, which for all intents and purposes is 100%. Does the table appear to be made to fit almost everyone? Okay, well, the answer is the table will fit almost everyone except for about 3% of the men with the largest sitting knee height. So in other words, what we're basically saying is that at a clearance of 23.7, okay, we're going to be able to accommodate 97.24% of all the men. So will it accommodate all of the men? Absolutely not. There's going to be a 3% chance that I'm going to run across a man who is not going to be able to sit at the table. Okay, but in terms of women, the 23.7 inch height is going to be successful in accommodating all of the women. So indeed, we're going to get all of the women and we're going to get 97% of all the men, but there will be some people that we will unfortunately not be able to accommodate. Thank you.